Let's have a look at a couple of ways of factoring 24. I'm going to start by putting a circle around it because it's not a prime number. Using my times tables, I'm going to use, let's start with 6 times 4. 6 times 4 is 24. Now 6 isn't a prime number, so it gets a circle around it. 4 isn't a prime number, it gets a circle around it too. Now I'm going to go and continue that process with each of the newly circled numbers. Now 6 we can break up into 3 times 2, like this. Now 3 is a prime number, so I'm going to put a box around that, making it red so it stands out. 2 is also a prime number. It stands out with a red box. Now I've got one number here that's in a circle, so I'm going to do the same process to that. Two things that multiply to 4 are 2 times 2, keeping note that I'm avoiding the use of 1 here. 2 is a prime number, and 2 is a prime number. So what I'm going to do now is I'm going to write down all of the factors of 24, and we've got 2, 2, 2, and 3. If we multiply all of those back together, we get 24, so that works. And if we want to write this in index form, we can write it like this. We've got 2 to the power of 3, and we've got a 3 to the power of 1, with that multiplication between them there, and that also equals 24. Great. Let's have a crack at 24 again and see if we can get a different looking tree. Okay, so we know that 6 times 4 pardon me, is 24, but we can also do 12 times 2 is 24. Now, the 12 is not a prime number, but 2 is, so we'll circle 12 and put a square around the 2. We'll leave the 2 alone and carry on with the 12. Now for 12 we can do 6 times 2, and again we can see that the 6 is not a prime number, but the 2 is a prime number, so we're going to put a square around that. Carrying on with 6, 3 times 2 equals 6. And both 3 and 2 are prime numbers. Put a square around them. I've got no numbers left that don't have squares around them, so I'm finished. And now I can collect all of the factors and put them back together. So I've got a 2, I'm just putting them in numerical order here, equals 24, same as before. And just like in the previous one over here, that can be written as 2 to the power of 3 times 3 to the power of 1. Equals 24. So two very different looking trees, got different numbers in them all the way through except for the end of course, but they end up with the same result, and that's true for all factor trees if they're done properly.